Hey, what's up, guys? Okay, so in this video, I want to give the interesting proof, which is I recently found it interesting. Basically, it's the Lipton proof. So it's like Lipton, and I think it's maybe in like 1990 or however. I forget about it. Maybe 20 years ago. And basically, Lipton's come out with the so-called worst case to average case or worst to average case reduction of permanent. Well, this is very interesting. So let me just tell you the story. So the story, because I found this proof is that people usually use in the paper, but there's no like maybe there's no such video that describe it carefully. So I want to like make step by step. Hope you guys subscribe to my channel if you want to see more complexity or however mathematics. You can check out my video. Okay, so all the results that previous people know is that, so for example, right, if you can for given n by matrices, so given let's say told some story, so given by matrices matrix, and let's say over a field, let's say integer, and you can define permanent, right? So permanent will be just ai sigma I, and the product of this, and oh sorry, maybe that's a, okay, and you take all the sigma belongs to Sn. Okay, so sigma is all the permutation. So basically, this is the determinant with no minus sign. Okay, so this is described by Weber. So determinant with no minus sign is defined so-called permanent. And we all know that the permanent is Sharpie-Hart. So this is by Valiant. Okay, so what this means that any counting function can compute. If you can compute permanent, then you can compute any counting function. Okay, so this worst case to average case reduction is interesting because the results basically say that the following. So following is Sharpie-Hart. Also Sharpie-Hart. Basically, it's that given the prime number greater than 0, sorry, greater than n plus 1, if there is an algorithm, so there's an algorithm O calculate, or there's a I should say if there's an oracle, if there's oracle A, calculate the permanent X over the finite field. Let's say finite field, right? So finite field, let's say P by n by matrices with large enough prime P. Basically, the output's probability. So basically, the probability that so basically you ask O, right? O input X and output the permanent of X with probability higher than, let's say, this over P by P. Sorry, n by matrices with field P greater or equal to 1 minus 1 divided by 3n. So there's if somebody give you this oracle, which you have this property. So this oracle is powerful that this oracle, right? This oracle is powerful that it will success calculate the permanent at least 1 divided by 1 divided by 3n fraction. So the only thing you know is that this oracle can give you the probability that higher, sufficiently higher, but you don't know which. You only get probability, which is uniform random, but you don't know which one is correct or not. So you just, there's no way that you can check because the permanent is hard to compute, right? So you cannot check in general. But this tells you that this oracle can have some strange property that can calculate at higher probability with the correct give you the correct answer with higher probability. Then you can turn this oracle into the weird you can run another algorithm which use this oracle and compute any permanent. So you can compute the permanence of X. So this X is the P n by matrices in the prime, well in the BPP to the O. So you can use the probabilistic Turing machine to with access to this or calculate. Okay, so this is the proof. Okay, so in the next video, basically I will prove this video. I will prove this in this video. In the next video, that I will give another like stronger proof that one can actually, so one can actually bound this guy to be like lower this guy to be like up to at least like 3 divided by 4 plus 1 over a polynomial n. Okay, so there is a much more like tricky much more detailed or the much more technical way to decrease this probability such that even though if the probabilities, if n goes to probability n goes to infinity, then this probability will be 1. If n goes to infinity, this guy will be 3 divided by 4, right? So in this case, that this guy is weaker. But in this video, let's focus on this. Okay, so the proof, I think everyone knows the proof, right? So proof is using the polynomial interpolation. Okay, so the idea is you just take A, right? So let's say somebody given you A, let's say come and give A is like n by matrices, and then you just take you just define okay, so you define A plus TB. Sorry, not let's say not A plus TB. Say however, let's say so this is bad. Let's say A plus T. Let's say B. Okay, however B. Okay, so this guy is choose B. Okay, so I don't tell you how to choose, right? So you just uniform. Okay, so you just uniform random. So you uniform random choose B n by matrices with prior field, and the call is this is A plus TB as a matrices, and you imagine that this guy permanent of A plus TB is a polynomial, right? At most n, so it's called C of T. So C of T is a polynomial with variable T with degree less or equal to n, right? Less or equal to n. By definition, right? You can check. Basically, it's the same as term determinant, right? Determinant is also the polynomial with degree T. Okay, and okay, so now everything looks like maybe okay. So check. So there's a okay. So you can consider T equals to like 1, 2, 3 up to like n plus 1, right? Okay. So the fact is the following, right? So you take T equals to 1, 2, 3, 4, n minus 1, right? So obviously that the non-trivial part is that if you take T to be 1, right, you're calculate A plus B. Okay, but I choose uniform random B. Okay, so actually the fact is that this A plus B is uniform random. It's the same as you just choose uniform random, right? Because you just shift A, right? So if you choose B uniform random, then A plus B will also be uniform random. And A plus 2B will be uniform random. The reason is that 2 is invertible in FP, right? Because P is greater than 2, and the P is also greater than n plus 1, right? So all these are invertible. Okay, so 2 is invertible. Basically, you can find inverse, so you can just change it into be 1. So you can imagine A plus some weird thing, but still uniform random, and A plus 3 of them, 3 of B, and 3 can be inverse to be other object. So 3 can be B inverse or whatever. Okay, 3 B inverse. Okay, so what I'm saying is that you can write this is the A plus 3 inverse B, right? So 3 inverse in MAP field. So this is also like one of, yeah, I mean, however. So basically it's, yeah, so basically you can write it as another matrices. Okay, so basically you just shift it. Okay, shift it. So all these are all true, all uniform random. Okay, so since there are true, then you can have the following, right? So basically you can just say I fix T from like 1 to 2 up to P n plus 1. That the probability. So I just put this into Oracle. Okay, so I put T equals to 1, 2, 3, n plus 1, then I put in this Oracle. So you can tell me that the C of T, the permanent of, so it's basically it is permanent of A plus BT, the same as Oracle of T. The probability of this success is doesn't success, right? It's less than 1 divided by 3n, right? By definition, right? So this probability means that for fixed any T, then I just choose uniform random. Okay, so this is random on what? Random on B. Okay, so I choose random on B. Okay, and then I fix T. For example, I fix T to be 1. Then I just do this. Okay. Okay, so that means that that means what? So I can use a union bound. Okay, so union bound of the I guess probability of B, which that the T equals to 1 wrong. So T equals to 1 wrong means that the C of 1 doesn't basically C of 1 different from like O of 1, or t equals to 2 wrong, basically C of 2 the same as O of 2, or C of 3 of 3 different up to C of n plus 1 different from O of n plus 1. Okay, so all of this less or equal to 1 divided 3n, and then you union bound, right? So at most n plus 1 events, right? So it's n plus 1. So it's if n goes to infinity, then you can say that this is infinitely close to 1 divided by 1/3. Okay. So we just prove the results, right? Basically means that okay, so you have probability, higher than 2/3, such that you can get a pair, you can get the correct n plus 1 pairs. Okay, so n plus 1 pair basically means that you can get the C of 1, which is you can get C of 1 is O of 1, which is permanent of A plus B, and the C of 2 is O of 2, you get permanent of A plus 2B, and the C of n plus 1, you get O of n plus 1, which is permanent of A plus n plus 1B. Okay, so all these are, and then we know that these permanent of A plus TB are polynomial at most degree n plus a, right? So you can, if I get all these pair correct, then I can use polynomial interpolation or Lagrange interpolation to compute, to find a polynomial. So I can find C of t, then I just put C of 0, where C of 0 will give me the permanent of A, which finish this worst case to average case reduction. In the next video, that there is a more tricky way to get this bound. So I think the idea is that in this case, right, you only use an n plus 1, right? But actually in this kind of proof, that you can suppose you go from t from 1 to 2 up to like p minus 1, right? So you can get more points, and so since you have more points, right, so you have more choice, so you will lower your probability. So actually one can prove the much stronger results. Okay, so next video we will prove the permanent worst case to average case reduction, like over like the more powerful results. Okay, so see you guys next videos.